Welcome to Brain Vision.
Okay, so once again, welcome to a new problem. Well, this time we still have an incline, and it happens to be at an angle of 36.9 degrees. There's a monitor right there on the incline, and it's being dragged all the way up by friction, which we're going to call FF, capital F, small f for frictional force. And then also remember the monitor is being affected by gravity. It's being affected by gravity, mg, which is resolved into two components. The vertical component is mg cosine of theta, where theta happens to be 36.9 degrees. And then on the horizontal, we have mg sine theta. The incline has a distance. So the mass m is 10 kilograms of the monitor. The distance or displacement distance, d, is 5.5 meters on the surface. And then the angle, theta, of the incline is 36.9 degrees. The velocity v is 2.10 centimeters per second. We're going to change that to standard units by multiplying that by 1 over, so 1, centimeters, changing centimeters to meters. 1 meter is 100 centimeters. And that gives us 0.021 meters per second. We need to find the height of the incline. So if that's the incline, that's the height h. That's the angle 36.9 degrees. The distance, d, that's the length of the incline, 5.5 meters. Trigonometry says that sine of 36.9 degrees equals to h over 5.5 meters. So that helps us get the height of the incline, 5.5 times sine 36.9, giving us a value for the height of the incline, which happens to be 3.3 meters. So this is going to be helpful. As you can see in the next page, we have to find, part A says that in the problem we have to compute the work done by friction. So work done by friction. Remember, work by definition is just the force times the distance, and the units for work is joules. So in this case, to get the work done by friction, we're going to take the frictional force times the distance of the incline. Remember, frictional force acts in opposition to the force pushing the object downwards. That force happens to be mg sine theta. So frictional force has to equal that for the object to move up the incline. This is F frictional force, so mg sine theta. So this is going to be mg sine theta times the distance traveled on the incline, and we can plug in the numbers. 10 kilograms times 9.8 meters per second squared times sine of 36.9 degrees times the distance traveled by the object on the incline, rounding up our answer to 323.9 joules. Okay, so that's what we get for the work done by friction. In the second part of the problem, part B, work done by gravity happens to be opposing. Okay, it's going downwards while the friction is going upwards. So work done by gravity is mg sine theta. Because the motion of the object is upwards, that's going to be a positive, and then gravity will act in the opposite direction. That happens to be negative. And so mg sine theta, work done by gravity, is on the negative side. So negative mg sine theta will still maintain the same character of force times distance. So 10 kilograms times 9.8 meters per second squared times sine of 36.9 degrees times the 5.5 meters. And that rounds up the work done by gravity. Okay, that rounds up the work done by gravity, which is negative 323.62 joules. Okay, negative 323.62 joules. Okay, so the object is moving upwards. The object is moving upwards, so it's opposing the gravitational force, and so that means that it's all going to be negative. Part C of the problem, it says we want to find the work done by the normal force. So this is part C, work done by the normal force. And we know the normal force is perpendicular to the incline. So it's like that, Fn. This is mg cosine theta. That's theta. This is mg sine theta. So, work done by the normal force is Fn times 0, because it doesn't move in the horizontal direction, so no displacement in the horizontal. No displacement in the horizontal. And therefore, you could also say this is Fn d cosine 90 from the dot product formula, and remember cosine of 90 is 0. So this is going to be 0 joules. So coming back, we just want to make sure that we got all the answers right. Work done by friction, work done by gravity, and then work done by the normal force. Another way you could solve this problem is by using the velocity. Remember, they gave you the velocity. So if you wanted to do work done by friction, you'd have the law of conservation of energy. You'd use the law of conservation of energy. And you can see from the incline that this height right here, the energy right there, gives us mgh. So mgh, and the object is moving upwards like this. Okay, so 1/2 mv squared plus work done by friction equals to mgh. So one of them has to be negative. You have to decide which one is going to be negative. Negative energy. The object is moving upwards. If the object is moving upwards, friction is opposing. So this becomes a minus right there. So you could have work done by friction equals to um, equals to 1/2 mv squared minus mgh, which is the same as m v squared over 2 minus gh. And if you compute those numbers, you get negative 323.39 joules. But this is just an option. You still get the same answers. You're using energy and velocity, and so if you plug in the numbers, you could see 10 kilograms. The velocity that we had before was 0.021 meters per second. 0.021 meters per second, and also that had to be squared. Okay, divide by 2. This is squared divided by 2, and then minus 9.8 meters per second squared. That's the g, times 3.30 meters. Okay, so you can do it that way. That's just a different way of doing the same problem, and you end up with the same answer that we had before. So this is 0.021 divided by 2, square that result, minus 9.8 times 3.3, and then times 10. It gives us a negative value for the joule. So just a different way of doing the same problem. I hope you enjoyed the whole process. You can see we had an incline with an angle. It's pulling. It's a monitor that's being dragged upwards on a surface with friction. Then so we have work done by friction. We also have work done by gravity. We have a work done by the normal force is going to be 0 because there's no displacement in the horizontal for the normal force. And then finally, just a different way of getting the same answer. Thanks a lot. Feel free to have share any comments, and if you have any questions, you can send them my way. Okay, bye bye.